the link to, okay, this is the link to slides. So you can just go to this link and follow along the presentation. So I'll just leave this here for a little bit. Okay. So then before we get started, if you are on the link, make sure to click on this link and fill out the form. That's the sign up for our ICPC newsletter. So make sure to stay up to date with all of our new events. Okay, and then, yeah. So then first we can talk about what a technical interview is. So a technical interview is often an interview used by companies during like an assessment of your skill when they're trying to recruit you for either an internship or some other full-time job. And the difference between technical interviews and other types of interviews is that they primarily test your technical skills, and they can take many forms, as you can see here on the slides. There are online assessments, there are phone screens, and there are in-person or virtual on-sites. And so online assessments are the online coding assessments that you typically get when applying to internships. And the technical phone screens are usually a one-on-one over the phone. So the interviewer calls you and they give you technical questions, and you explain to them over the phone your thought process and how to solve them. And the in-person is what you would expect of a typical interview. You go on site, you sit in front of the person or persons, and then you do the same interview there. So despite having all these different types of interviews, the main idea of all these interviews are the same, and tackling them are also the same way, and uses the same approach. So we'll be talking about the technical skills used in these interviews and how to approach them. Okay. So what is typically asked in a technical interview? So typically they'll ask you some coding questions where they want you to write a short program. They give you a bunch of inputs, and you should write a program to output whatever problem they want you to solve. And typically after you solve this problem, they will also ask you some follow-up questions on space and time complexity, which we'll cover later on in this presentation if you're not familiar with it yet. And sometimes they'll ask you on how to improve your program in terms of efficiency, because oftentimes there are different ways to solve the problem. And they might ask you, okay, so given that you've solved this problem this way, can you make your program faster? And then you'll have to explain yes or no. And then, yeah, so as the third bullet point says, these questions are aimed to test your knowledge of data structures and algorithms primarily. But also another thing that is often overlooked is your communication skills. And they want to hire someone that is able to communicate their ideas and someone who is easy to work with. So it's not just about knowing these topics, but also how to communicate them. Okay. So the process is typically described, you can see here in this diagram. There are many different ways to contact the recruiter. So you can apply online, you can contact them through referrals, for example, connections, or you can just find their contact online and email them. But after that, the overall process is the same. So there's multiple levels of screening. It could be online, it could be a phone. There could be multiple levels, so multiple phones. But in the end, you'll be going through these technical interviews, and then you have to pass them one by one until you finally get the offer. Okay, so then we won't really be talking about behavioral questions, but I just wanted to briefly mention that there is a different type of interview or different types of questions that interviews might ask you. So behavioral questions are meant to test how you would behave in a certain situation. And the aim of these questions is to try and gauge what type of person you are, your thought process, and how you handle different types of challenges in your work. So for example, in this table here, you can see many different topics of what these questions aim to ask about. So one typical question they might ask is, give me an example of a challenge that you faced before and how you overcame it. Or maybe give me an example of how you worked in a team. So those are just two examples of typical problems that you might expect from a behavioral interview. And it's not too likely, but sometimes they might mix behavioral and technical questions. But for this workshop and for this quarter, we'll just focus on technical questions. And so there's a really good book called Cracking the Coding Interview, which the table on the previous slide was is also in this book. And I highly recommend this book if you're trying to prep for interviews, because it covers a large variety of topics that commonly appear on coding interviews, and it has a lot of good practice problems. And it also goes over some typical behavioral questions. So if you need good prep, make sure to check out this book. Okay, so how do you prep for a technical interview? And the answer is, like a lot of other things, is just practicing. The more you practice like the real thing, the better you'll get. And here you can see it's communication plus problem solving. So it's not one or the other, but both. Yeah, so here's just a short comic panel about what work is like, but the interview is often harder than the actual job, and that's just how it is. Okay, so the focus of this workshop is to teach you the tools necessary for how to practice for technical interviews, to teach you the common topics used in these technical interviews, and how to improve your communication skills and explain your thought process. So far, if you have any questions, please let me know. And if there's no questions, we could just move on. Yeah, so feel free to put your questions in chat as well. I'll just wait a minute to see if anyone has any questions. Okay, I think we can move on then. So for the technical interviews, you can choose any language that you're comfortable with. And oftentimes, the primary languages are C++, Python, and Java. A lot of companies might look for something else, but these are the three main languages. So if you're more skilled with C++, just do your technical interviews in C++, and same goes with the other languages. Okay, so then now I'll talk about Big O and what it is, because this is a very important topic that you'll definitely need to understand for technical interviews. So Big O is a way of analyzing time and space complexity. So time complexity in this case is how fast your program runs in terms of operations. And space complexity, you can also think about it like memory complexity. So that is how much memory your program takes. So you can see that it's not always the same for every program. Okay, and then so the format of big O is you say O of some complexity. And when you calculate big O, you want to drop all the coefficients inside your complexity. So the example I have here is O of 5n becomes O of n because we only care about whether or not it's linear, it's quadratic, or it's cubical, and so on. So O of 250n squared just becomes n squared. So as a practice problem, what does the expression O of 3n cubed plus 5n squared plus n become if we want to keep the maximum term? Oh, I have a question. Yeah, so space doesn't encompass software limitations. Okay, yeah, so Jeffrey says O of n cubed, and that's correct because the program is bounded by n cubed. So n squared plus n just becomes irrelevant as n gets very large. Okay, and then another example I have here is, let's assume we have a list of n numbers. Then the big O of searching through each number once is O of n because that's linear time. So hopefully this gives you a basic understanding of what big O is. And I think I have some additional practice here. So assume that we have a list of n numbers. Then what is the time complexity to generate all subsets? So the code is separate problem, so don't look at the code. Just okay, so someone says O of n squared, but remember that a subset can be lengths 1, 2, 3, and so on. Yeah. The complexity is actually O of 2 to the n because for each of the n numbers, we have two options. We can either choose it or we don't. So that's 2 to the n choices. Right. Okay. And can someone tell me what the space complexity is? So that's just the amount of memory we're using. Okay, yeah. So we have a question. Can you explain the difference between O of n squared and 2 to the n? So 2 to the n, and so think about n as just a variable. So 2 to the n, if you graph it out, like y equals 2 to the x, for example, it's gonna grow at a faster rate than y equals x squared. So there's just two different ways of modeling how fast the number of operations your program uses and how it grows. Yeah, and the code is just two other separate practice problems. So then for the space complexity, in this case, it would be O of n, since we have n numbers, and that's it. So we just need to store n numbers, so it's O of n. So then for additional practice, we just have two other small problems, since you'll need to be able to analyze your code when you finish coding it and tell the interviewer what complexity your program runs in. So can someone tell me what the complexity of the left program is? Of n squared, yeah. So that's correct because we have a nested for loops right here. The outside loop runs in O of n, so it runs n times, and for every iteration of the outer loop, we run n times again, so it's n squared. Okay, so for the right side, here, I'll just tell you, we have a code for binary search. So if you're familiar with binary search, maybe this will tell you something about the time complexity. But if not, can someone guess what the time complexity for this is? Right, O of log n. So that's correct, because we have a range of n, and every time, as you can look here, we're splitting the range in half. So we're either moving the lower bound of the range to the middle, or the higher bound of the range to the middle. And every time we're cutting the range by half, so there was log base 2 number of steps. Okay, so hopefully everyone has a understanding of big O. So then in this case, we can move on to some warm-up problems. So here in this warm-up problem, you're given an array of integers, as you can see in the example input here. And you want to write a program to move all the zeros to the start of the array and keep the relative order of every other number. So you want to output 0, 0, and then just the rest of the array in the same order. So maybe spend a few minutes to think about how you can approach this problem, and then I can talk about some approaches. If you would like, I can create breakout rooms, and you can just join the breakout rooms to discuss. So I think that's a good idea. So let me just figure out how to do that. Okay. Yeah, so I created breakout rooms, and you can just join them to talk about problems.
Justin, do you wanna, or Ryan, do you wanna go to room 7? There's only 2 people. They sad. And Ryan's quiet. Justin, go to room 7.
I can go. Sorry.
Okay. I guess I'm
I'm muted. I can hear.
guess
Oh,
I'm not going then.
what'd you say?
I guess I'm not going because Ryan's going.
Is Ryan going?
Yeah, he said he's going.
Okay. Neo has reported dead silence. Oh, wait. Oh, that wasn't for you. Oopsie. You didn't hear that?
Okay.
How'd it go? Ryan. 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 Bro, Ryan's gone.
Why do you scare him?
I'm so nice. I don't know what you're talking about.
Uh,
Should probably go
uh-huh.
facilitate though. If they did.
What room?
I'll just go around. You can go from room 7 and then to 1, and then I'll go from 1.
Okay. Okay, so it looks like everyone's back. So if everyone or if anyone came up with some idea and would be willing to share, it'd be great if you could offer some ideas. Yeah, feel free to type in chat. So just wait 1 second while we wait for Jacob to type his idea.
While we're waiting, we do have one person who's willing to talk about their idea.
So first I was thinking that once we encounter a zero, we just move the zeros to the front and then kind of shift all the elements over, but that's slow because in a big array, that would just take a lot of time. So then, yeah, I think, yeah, I arrived at the same solution that Jacob has, just like count the number of zeros, make a new array, fill zeros, then populate going through the old array.
Yeah, so that's a correct solution. So just to reiterate what Dylan was saying, is we first go through the array and count the number of zeros, and then we create a new array with that number of zeros, and then we can go through this array again, and for every non-zero number, we just add it to the position in the new array. So yeah, so this problem has multiple solutions, and the one I described here is the same as the one that Jacob and Dylan described. So you just go through the array, or it's slightly different, but it's essentially the same, where you go through and add all the non-zero elements to another array and keep track of how many zeros there are, and just add all the zeros to the front of the answer and append all the non-zero elements to the end. So hopefully that makes sense to everyone of how we can push or move all the zeros to the front of this array. Because one important distinction when you're solving problems is that you don't want to put unnecessary constraints on yourself. So if you were thinking, oh, you can't create a new array, well, you can just do that and it would make your life a lot easier. So I see we have a question from Daniel. Yeah, go ahead.
Were we looking for just the most direct solution, or are you taking any?
Usually, so I'll get to that in 1 second, but usually any solution is fine. And oftentimes the interviewer has a, I'll call it just a goal complexity that they want you to get to. So maybe you think of a O of n squared solution, but the interviewer in their mind has a O of n solution. So that is the solution that they want. But I don't really think they care what O of n solution you get, as long as it makes sense to them and you can explain it well enough. Does that make sense?
Right, within the specific goal complexity in mind.
Right. Okay. Yeah, so then the time complexity here is O of n. And to analyze this, we can just think about the number of operations we're doing. So one, we're going through the whole array once to count the number of zeros there are, and adding all the non-zero elements to another array. So that's n number of operations. But then we need to add all the zeros to the front, and that is at most O of n. So O of n plus O of n is O of 2n. And based on how we calculate big O, we want to drop the coefficients. So it becomes O of n. And if you were to do the same thing with adding zeros to the other array, it would also be the same complexity if you think about it. And the space complexity in this case is O of n because you have an array, so that's n numbers, and then you also generate a new array, so that's another n numbers. And you can do the same thing, you get O of 2n numbers, which is the same as O of n. Okay, so if we don't have any questions, I can go on to a better solution, which if you've thought of, that's great, but it's not expected that you think of the solution. It's just to show that there are often multiple solutions to the same problem. And it doesn't usually matter which solution you get, as long as it's a working solution and it's within the time complexity that the interviewer wants. So in this case, I'll move on to the better solution. And this might be confusing to some of you, so if you have any questions, make sure to ask them. So first, we have an array, and let's define a variable called index equals to n, which is the last position in your array. And we know that all the zeros end up in the beginning. So let's start from the end of the array and move toward the beginning. And for every number that isn't 0, we set the position index in the array to that number, and then we decrease index by 1. And then afterwards, we just set all the other numbers that aren't set to 0. And this would be O of n, but if you look at the space complexity, it's actually constant space, since we're only using an additional 1 variable instead of creating a new array. So of course, you can say that it's O of n since you actually have to store the numbers, but it's essentially constant space since you're not using additional memory. So is anyone confused about how this approach works? Because I think it's a bit concise. Okay, so I don't see any questions, but I'll just explain it. I'll try to explain it in a slightly easier to understand way, since I think it's pretty confusing for some people. So essentially think about index as the position of the current number that you're trying to fill up. So you start with an array and index starts from the last number. So since you want to keep the relative order, let's start from the end of the array and move toward the beginning. And every time you hit a non-zero number, yeah, so this solution is modifying the input array in place. So if you go from back to the front of the array and you get to a non-zero number, you know that it's not at the beginning since it's not a 0. But you know that the position in the answer is index. So you set the position of index to that number, and then you decrease index by 1, and then you move on, you keep going. And you don't care about the zeros since you're essentially just setting some number of spots in the beginning to 0. So if you process all the non-zero numbers, everything else you know is 0. So that's the idea behind this solution. Okay, so if we don't have any questions, I think we can move on. But the purpose of this was to show that there's oftentimes there's going to be a better solution than the one that you think of. But as long as you get to a solution that the interviewer thinks is fast enough, and also you explained it good enough, then it's okay. So it's not like there's one ideal solution that you have to get to. As long as you back up your solution and it's good enough, then you'll do fine. Okay. Oh, and one distinction I want to make clear is that the interviewer is there to help you. So if you don't have a completely formulated solution, you can just bounce ideas off of your interviewer, and they'll oftentimes try to guide you toward the solution that they want. So the more ideas, the better. Okay. So here I have a table of data structures, and don't be scared looking at this because you won't need to know this, or at least you won't need to memorize this table. You just need to, you will need to know some of them, like how fast is it to access an array? How fast is it to insert or modify an array? And these are some of the data structures that we'll be covering in this workshop, this series of workshops over this quarter. So make sure to check out the later workshops. We'll definitely be covering these in detail and explaining how to solve problems with them. So for now, this is just a preview of the things that we'll be using and teaching. Okay. So here is kind of a short list of how to approach technical interviews and what you should be keeping in mind when you're doing technical interviews. So first, you want to reformulate the question in your own words. So this helps yourself understand what the problem is asking. And once you understand the problem in your own words, you want to check with your interviewer to make sure your understanding is correct. So you can ask them, just to clarify, is this what you're asking for? And if there's anything unclear, then you should also ask them, such as assumptions or bounds on numbers, for example. And we have some other practice problems after this that should show you some examples of assumptions that you commonly should check for. And after you understand what the problem is asking for and the interviewer has confirmed that, you can go over examples. And of course, this goes hand in hand with clarifying what the question is asking for. So if they still don't understand, you can say, let's assume I had this example. Is this the answer? And if it is, that's good. And then you can start thinking about solutions. Okay, so then the fourth step is brainstorming solutions. And after you have a solution, you want to start writing the code. And it's not pseudocode. So this is actual working code. But most of the time, you won't be compiling your code. So it's very important to be able to write syntactically correct code that will run if you compile it, but they won't have a compiler for most of the time. And it's also good to have good code readability. Yeah, and then the last step is just to test your code and make sure that it's correct. So again, a lot of times there is no compiler, so you would have to run an example just manually through your code and explain the steps. Okay, so then that's the steps that you should keep in mind when tackling these technical interviews. And when you're practicing, I would say the most important part is step 4. So brainstorming the actual solutions, because communication wise, it's not too bad to check for assumptions and clarify what the question is asking. But if you can't brainstorm the solution, you're not going to pass the interview. So make sure to be able to solve the problems. And that's what this workshop is here for. We'll be guiding you through how to come up with these solutions and explain them effectively. So any questions so far? Okay, so it doesn't look like we have questions. So then in this case, we can move on to the practice problems. Oh, we have a question. Let's see. Are we going to do mock interviews at the end? Yeah, that's a good question. So this quarter, we're trying a new format for our workshops. So since this is the first workshop, it will be slightly shorter than the other ones. But in general, we'll try for around 1 hour to 1.5 hours of presentation for our workshops. And then the last or the remaining time for our workshops will be opening up to mock interviews. Oh, at the end of 9 weeks. Yeah, well, so we'll be doing this at the end of every workshop. That's something new that we're trying. So if you want to join, we'll be opening up breakout rooms, and then hopefully we'll have enough officers for everyone, where we can just do a like a smaller session for everyone who wants to practice mock interviews, and then we can guide them through the problems and give feedback. So yeah, hopefully that answers your question. Okay, awesome. And additionally, we're also trying to host office hours weeks, I think. Trying to think here. I think it was 5 and 8. Correct me if I'm wrong.
Yes, week 7 and 8.
Okay, yeah. Since yeah, so I think weeks 5 and 8 are midterms weeks. So we're not gonna have workshops those weeks, but we'll be having this Zoom meeting open in case anyone wants to, yeah, stop by and vibe or just ask us any questions or practice, practice interviews. So yeah, with that said, we can move on to our first practice problem. So yeah, so here's the problem. I don't know if it's blocked, but hopefully you can see that. I'm just
Does this one have a leak code link to it? She said I can't see the speaker notes on the slides. So if there's a leak code link, could I have it in the chat?
yeah, I might have to direct you to Neil or Katie or Ryan for that one.
Okay, got it. Thank you.
Mhm. Yeah, so we can spend a few minutes thinking about this problem, and I'm not sure how well the breakout rooms worked, but I think some of them were pretty quiet, so I'll just keep everyone here. And if you have any ideas, feel free to put it in chat. Or if you're shy, you can just privately message one of us. That's fine too. Okay, so I see sort the array. Yeah, so that sounds like a good idea. Okay, so I have a good question. How do you find how do you find the array length? So usually for problems given, you can assume that it's just some number n. So in interviews, a lot of the times they'll just say you're given n numbers. So you could just assume for your for loop, you can iterate from 0 to n. And because there's no compiler, it's not going to throw any errors. It's just conceptual, but they want to see how well you can write your solution and put it into code. If you're looking for the size of an array, like in terms of the number of numbers, there is a way, but it's not that clean. Yeah, so it's easier to do with vectors, but if you really want to know, I can try figuring it out. Let me see if I remember. Okay, so I think that should be enough time for everyone to think of some ideas. Okay, so a linear solution with the additional array dictionary could possibly work. Yeah, could you elaborate a little more on that? Because that's definitely on the right track. Okay. So that is a working solution. And for the people who don't know what a dictionary is, that's perfectly fine right now. But I'll just give a simplified explanation of what it is. So the solution is essentially, we want to go through this array and keep a data structure. So think about it like an array. And every time you hit a number, you mark that position in our data structure as, let's say, 1. So whenever you hit that number again, the spot in your other array is already 1. So if it's already 1, you know that this number has appeared twice, so it can't be the single number. So that's essentially what a dictionary is doing. You have a position and you can just update that position in your dictionary. So we go through this array and just update each position of each number. And if one of the positions is, it doesn't have a hit. So what I mean by hit is if it doesn't have a check where that spot is 1, then you know it's the single number. So this is definitely a solution that would pass an interview if you got this problem in the interview. I also saw people saying you can sort the array, and that is also another solution to this problem. So if anyone can explain how we can use that to solve the problem.
I was thinking, oh, never mind. Oh, can I go? Or
Yeah, go ahead.
I was just thinking like after you sorted the array, then you could use binary search to like figure it out or something. Like in the sense that if you compare two like consecutive numbers and like and the first index is one that's even and the second one's odd, if they're different, then you know that uh like the thing is either on it or like before it, and you could use binary search that way.
So why do you need binary search in this case?
I was thinking because faster than linear time.
Okay. Yeah, so that's a good approach. So essentially what you're saying is you want to check. So are you doing binary search after sorting or after you check every pair of two?
I was thinking after sorting it.
Okay. Okay, we have a raised hand. Jacob?
To elaborate on an idea similar to Jeffrey's, what we could do is, yeah, so after we sort the array, we could iterate through it again, but this time, when the index is even, you want to store the number in a temporary variable, and when the index is odd, you want to check that the current number in the array is equal to the one in the temporary variable. And if it's not, then one of them is obviously the single number.
Yeah. So both of those are correct. Just a quick correction. You want to store the odd one in the variable instead of the even one. Or I guess it depends on how you're indexing it, but let's assume you start at 0, then you would store the even one. Yeah, so that's correct. Let's see, I can explain it again just for people who might not understand it. So you first sort the array, so all the numbers are in relative order. And since the numbers are sorted and you're guaranteed that every number appears twice except one, you can check every consecutive pair of numbers. So the array would look like 1, 1, 2, 2, and 4 for this input. And if you check 1 and 1 and they're the same, then you know that there's a pair. And then you move on to the next pair. And you keep doing this until you get something that is different. And so if you get two numbers that are different, you know that one of those numbers is the single one. So after you know that, you have multiple ways of finding which one's the single one. But I think a straightforward way is just to go through the array again and count how many times one of the numbers appears. And if that number appears twice, you know it's the other number. So that is also a perfectly valid solution. And I think that would be sufficient as well. Okay, so I hope that was good practice for everyone. So in that case, we could move on to the second problem. And just a heads up for the third and fourth problem, we're not expecting you to be able to solve them. They're just a preview about potential interview problems that may come up, and we'll be going over how to solve those later on in the quarter. Yeah, so problem 2, I'll give everyone a few minutes to think about it. Hopefully it's not too bad. Okay, I see a lot of good ideas. So let me just go through them. So Dylan says, mod 2 until the number becomes 0. And if we ever have a remainder, output false. I'm not sure which the
Sorry,
one.
I explained that so poorly. So like we could do mod 2, and if the remainder is 0, we'll divide it by 2. And then we'll check if the number equals 1. So if we get all the way through with no remainder and it goes to 1, then we know it's a power of 2. And if we ever do have a remainder, then it's not a power of 2.
Yeah, okay. Yeah, so that's correct. Essentially what the solution is doing is, as long as the number is divisible by 2, you keep dividing. So if the number is a power of 2, then after you divide out all the 2's, it should be 1. And if it's anything other than 1, then you know it's not a power of 2. So I also saw another solution. Let's see. So Daniel says, check the rightmost bit and see if it's 1.
No, I kind of just wrote down what I thought down immediately, but that's not right. My idea was just to do some bit, just checking the bits, and powers of 2 only have 1, I think, assuming we're not looking at negative numbers.
Yeah.
Do some for loop where we kind of just shift and just continually just track, I guess, the number of 1s.
Yeah. So first, I want to go through all the solutions that don't use bits, just in case there are people who don't know what a bit is yet. So I see Michael also has another solution. You can keep squaring 2 until you either get the number or you get 2 values that are above and below the integer. So this also works because essentially you just keep multiplying 2 by 2 until you either pass the number or you get to the number. So intuitively, I think that's easy to understand. Okay, and now I'll talk about a solution with using bits. So in case you don't know what a bit is, if you're familiar with binary numbers, you write out all the bits, so you write out the integer in terms of binary, and each one of those 0s and 1s is a bit. So if you think about it, a power of 2 will only have 1 bit that is 1, because each one of those 0s and 1s in binary is a power of 2. So now that you know this, you want to check if there's only one bit in our number. And there's many ways to do this. One of the ways is to repeatedly shift the 1 toward the right until you get a 1. So that's the same as the one Dylan was saying, where you divide by 2 and check if it's 1. And let's see, so the next slide, I have the solution. On the left, it's the solution that we were talking about before. As long as x is greater than 1 and it's divisible by 2, you divide by 2 and just check if it's equal to 1. On the right, we have a more concise solution. It's just to show you, I think it's a pretty cool trick. But essentially what we're doing here is, let's say x is a power of 2. Then if you subtract 1, you'll get, okay, it's a bit hard to explain this, but let me see if I can explain this in chat. I think it might be a little easier. So, oh, I can type on the slide. Is that a thing? Oh yeah, sure, okay. Actually, I think it's fine. It might be easier to see in chat instead. So we have 8 equals that in binary, and we have 7 equals that in binary. So whenever you subtract a power of 2 by 1, it just becomes all ones, but up until the position of the 1 that the power of 2 represented. So if you had a number like that, then and you subtract by 1, then you would get that, if that makes sense. Or I think I put it extra. You get that. So what the right function is doing is, if it's a power of 2 and you and x with x minus 1, then you can see that it should be 0. Because 1, oh, what does and do? So and is the and operation. It takes in 2 numbers, so a and b. In this case, a and b are both zeros or ones. And the output is only 1 if both a and b are 1. So essentially it's saying, is a and b both 1? Otherwise it's 0. So if we do, yeah, so it's bitwise and operation. So if we do 8 and 7, we get that. And you can see that for every one of those columns, that's a bit. You would and the first column, second column, third column, and just put them together. So you can see that it's just 1 and 0 for every column, which becomes all zeros. And if you not 0, you get 1. So that's kind of a neat trick on how to check if a number is a power of 2. And this involves some bit manipulation, which you don't really need, but I think it's useful to know. Manipulation. Yeah, so any other questions about how either one of these solutions work? Okay, and I guess before we move on, can someone tell me which solution they think is faster? Or do they think it's the same? The right solution. And why is that? Mm-hmm. Yeah, so the right one is actually O of 1. So what is the complexity of the left one? Log 2. Yep, that's correct. And it's log 2 because we just keep dividing by 2 until it's 1 or not 1. But there's at most log base 2 number of operations. And just as a review, O of 1 means constant. So it's basically 1, or it's not 1 operation, but it's a constant number of operations. So you can say, O of 1 million, that's technically O of 1. But in this case, we would say the constant factor is really bad. And what I mean by constant factor is the 1 million. So it's think about it like the coefficient. So you can have O of 1 with a really bad constant factor, and it might be slower than the O of n with a very good constant factor. Yeah, so if you ever need to explain your time complexity and you mention constant factor, I think it would definitely impress your interviewer. Okay, so then we can move on to problem 3, but as I said before, we're not expecting you to be able to solve problems 3 and 4. It's just a preview on what we will be teaching in the later workshops. But these are all common questions in interviews. So I think I'll give a few minutes just in case people want to think about these. But otherwise, if you have any ideas, you can just mention them. And we have a few slides after this, so we can just skim through these without taking too much time. By singly, there's multiple ways, as Neil says, to represent a linked list, but singly just means when there's one direction between every two adjacent nodes in the linked list. So A connects to B, but B does not connect to A. Yeah, so there's no pointer backwards. Okay, so Jacob says, copy the list and reverse it, iterate through both and compare one by one, and terminate if something doesn't match. Yeah, so that's exactly the solution. Here for this problem, we can assume that we have a function to reverse the linked list. And this is often not the case because you typically don't get helper functions, I would say, unless it's a more tricky problem. But if you want to use a helper function, you would have to write it yourself in interviews usually. But here we can just assume we have a function to reverse the linked list. So you can reverse the linked list and then compare it with the original one. And you go from the beginning one by one for the node. And if one of those nodes is not the same, then you can just output false. And otherwise, if you make it to the end, it's true. So just to clarify, a palindrome is something that is the same if you write it forward or backwards. So as an example is typically taco cat or race car. And I know there's a space, but if you put the two words together, it's a palindrome. So, okay, what's the difference between null and null pointer? I am not 100% sure what the difference is, but typically I use them interchangeably. Yeah, I think Katie has a better answer. Okay, so I think we can move on to the fourth problem just to give you a sense of some other topics that we'll be covering. And this one is slightly trickier. I don't think it's covered in CS32. Oh, I see DP. Yes, that is DP. So that's very good. So any ideas on how you might do this? Oh, so what is DP? That's a good question. So DP stands for dynamic programming, which is a technique. So it's not exactly an algorithm, but it's a technique that you can use to decompose a problem into subproblems and solve them by building upwards. Yeah, so it's typically covered in 180, but we'll also cover it in a later workshop. And if you're curious about DP right now, you can think about it like recursion. So it's essentially recursion, but you put a little twist to it. So it doesn't look like we have ideas for this, but that's fine. It's meant to be a challenge. Iterate from 0 to floor of n/2. Okay. If you're not, no, Genesis steps does not floors.
Sorry, I'll just say my potential solution out loud.
Mhm.
But I mean, I guess it's more of an idea than a solution. But because one, is just the most basic integer, you can make anything with a set of twos and then fill in the remainders with ones. And then obviously the maximum number of twos you can have is the floor of n/2. So, for example, you can have all ones, or you can have 1, 2, and then fill in the rest with ones. Or you can have two twos and fill in the rest with ones, and so on.
Yeah, so that is one way you can approach it. But if you calculate out how many operations you need, this might be a bit slow, right? Because depending on how big n is, you can use up to n/2 number of twos. And then for every single number of those twos, you have to calculate how many combinations there are, because the order matters in this case. So if you have a step of 2, 1, 2, it's not the same as 1, 2, 1, or like 1, 2, 2. So the solution would work, but it's not exactly the fastest, and we can do a lot better. So I see that I could just we can use a DIS approach. I'm not too familiar with what a DFS. Could you explain a little more on that?
Yeah, so if we start on the first step, we could either go up one step or we could go up 2 steps. And then, so let's assume we go with the first option, we go up 1 step, then we could either go up 1 step or 2 steps. And so that would kind of like represent like the recursive approach to this, kind of, right? Maybe. And so like once you get to the top, that would be like one solution. And I don't know. I don't really like, I don't know how to explain it, what I'm thinking too well, but that's like kind of like the high level idea, I guess I would be thinking about.
So like that, right?
Yeah. Yeah.
Yeah. So if you break down the problem like that, then that is correct. So if you're not familiar with DFS, that's perfectly fine. We'll be covering this as well in a later workshop. But essentially, for a given number x, you know the number of steps. Let's see. So first, we can assume that once you reach DFS of n, that's one solution. And then as you backtrack, you can add together these solutions. So you know that for some number x, the number of solutions, or the number of different ways you can get from x to the top, is x plus 1, so DFS of x plus 1 plus DFS of x plus 2, if that makes sense. But there's one small problem with this, and the problem is that you'll be entering or you'll be calculating the same thing multiple times. So let's say you start from DFS 0, then you'll be calculating DFS 2 multiple times because you can get from DFS 2, you can get to DFS 2 from DFS 0 and DFS 1. So you can see that you'll be calculating the same thing over and over, and this would waste a lot of computational power and time. So this is where dynamic programming comes in, and I'll just write out the solution here. But essentially, you want to do that. So this is the transition where you start from DFS 0 equals 1, and then you just output DFS, or sorry, DPN at the very end. And I won't go into too much detail about how this works yet, but we can always come back to this problem when we cover dynamic programming. Yeah, but as you can see, it's very similar to the DFS solution that Dylan was talking about. So they do go kind of hand in hand. It's just a optimization on top of recursion. Okay. So with that, here are some additional practice problems, but you're not expected to solve them at the moment. In case you're curious, you can definitely check them out. So I wanted to talk about some of the topics that we'll be covering this quarter in a little more detail. So we'll be covering linked lists, vectors, and hash maps. So all of these are data structures to store data, and they're very helpful in many different types of problems. And we'll also be talking about stacks and queues, which is also two other very important data structures. We've all seen dynamic programming from the last problem, so we'll be talking about that, as well as advanced recursion and graph theory. And in the end, even after you know all of these topics, it's important to be able to elaborate your thought process. And that's what's most important, is to be able to tell your interviewer what you're thinking, how you're approaching the problem, and be able to communicate it such that if you think about it from your interviewer's perspective, they're trying to evaluate if they want to work with you. So if you can't communicate an idea that well, it might not be such a good sign. Okay, so then here's some more problems, but we were planning to leave these for anyone who wanted to do a mock interview. So I would say that's it for this week's workshop. And if you are interested in doing a mock interview, feel free to stay around. Otherwise, thanks for coming, and I'll see everyone next week.